So this is our second significant E8 projection, seed 48, a completely different way of folding the same 8-dimensional lattice onto the Earth, where seed 3 was oriented at 65 degrees north, 125 degrees east. This one looks at 5 degrees south, 135 degrees east, nearly antipodal, yet it produces its own statistically significant alignment. So you are looking at all 6,728 edges with 160 circuit sites colored by proximity, green within 5.6 kilometers, yellow up to 17 kilometers, and red beyond. So there's 83% of all sites, which is about 133 out of 160, fall within just 0.05 degrees. So it's about 5.6 kilometers of an E8 edge. So that means if you randomly rotated this grid 200 times and optimize each one, only about 5 of those 200 trials will match what you see here. So that fraction is very significant at P equals to 0.005. Only 1 in 200 search optimized random trials could match this. So what is remarkable is that this is a tighter threshold than seed 3. Seed 3 strength was breadth, so 97% of sites were within 11 kilometers. For this particular projection, seed 48, strength is density. It packs more sites into the ultra close core. So now I'm going to present you layer 2, the supported edges. So now I'm filtering really to show only the 198 edges that pass within 5.6 kilometers of a site. So that's just 3% of the full lattice. Yet these edges account for 133 circuit sites. So notice the distribution of connectivity here. So we have Golden Hind in British Columbia, and Cerro de la Silla in Mexico, which I'm zooming here. Each sit near 6 edges. So there are major nodes in this particular projection. Mount Damavand in Iran. So if we go there, and St. Helena Island in the South Atlantic have 5 edges each. So you can see here there's 2 edges here, and then 3 from pretty much from south to north. So comparing with the first projection, seed 3, where Mecca and East Langila falls were the top nodes. Here we have different projections with different hubs, but the same underlying mathematical structure produce the alignment. So now we look at the layer, the third layer, which is the most meaningful in this analysis. We're looking at shear edges, which present in this projection 7 edges connecting at least 2 sites or more. So you can see here we've got Kashina Peaks Wilderness in America, and then if we carry on along that line, it'll share the same edge with Nuuk, Greenland. And also, same as the first analysis, the first projection, seed 3, we have Easter Island again appearing because the sites are quite close to each other. Easter Island, Rhino Arrow and Rhino Koi share also the same age. So these 7 ages are the connections that matter most. Each one passes within 5.6 kilometers of 2 or more sacred sites simultaneously. Some of these pairings echo across both projections, seed 3 and seed 48. So in both cases, the age passes within 12 kilometers of all 3 sites. For this one, Easter Island, Rhino Arrow and Rhino Koi. Bermuda's 2 sites, St. George Island and Somerset Island, if we go there, share ages as well in both projections. But seed 48 reveals new connections that seed 3 didn't show. Glastonbury Tor and Shaftesbury in southern England share an age at just 17 kilometers from both sites. So if we go to Glastonbury, we'll see this age again. Yeah. Well, we see the age here, passing to Glastonbury Tor near, not far from Shaftesbury as well. Then we have Tanked Suleiman, an ancient Zoroastrian fire temple in Iran, appearing on 2 separate share ages. So one connecting it to Barcelona's Plaça de Catalunya, the other to Pico de Teide in the Canary Islands. So these are not connections we went searching for, okay, in this analysis. They emerge from a single mathematical optimization across all 160 sites. 2 independent projections of the same 8-dimensional lattice, but both statistically significant, both producing their own distinct network of ley lines, with some connections appearing in both. So to put this in perspective, we have now tested 50 different E8 projections. Only 2 survive the full search BS correction, seed 3 and seed 48. They have completely different orientations, different hub sites, and their statistical signals come from different parts of the distance distribution. Seed 3 excels at coverage, nearly every site within 11 kilometers. Seed 48 excels at precision, most sites within 5.6 kilometers. So both achieve what random chance cannot, and together they suggest that the relationship between E8 geometry and sacred sites placement is not a single coincidence, but a structural property of the lattice itself. And this is what I'm studying and trying to understand through different analysis. And there will be more batches I'm going to analyze, more projections of the E8 lattice, and see if there is anything interesting. And lately I have also discovered a third projections which share the same bearing as seed 3 and seed 48, which is interesting because what is the chance of 3 different projections of the E8 lattice sharing the same bearing, same orientation. So it could imply the E8 lattice has a privileged orientation for this particular data set of 160 sites. And it will be good to analyze what makes it privileged. Why is it this particular bearing the E8 lattice aligned to? There might be more than just one, and that will be the next steps. To the more projections of the E8 lattice I study, the more data I get and the more information I can interpret from, and the results I can compare and interpret and conclude with rigorous mathematics, statistics. So that was the projections seed 48 of the E8 lattice, and I'm going to finish now, and I'll come back next episode for the next projections, which will be seed 46, and it will be a total different data information, different from the seed 3 and the seed 48 projections. Thank you very much, and see you soon. Bye for now.